Okay, hello everyone. So there's been a bit of a buggy start to this stream, so I started again. Well, we're going to make a few cleanups and some design decisions on how things are going to go. So we're at a crossroads here. We can use vectors and object-oriented, not object-oriented, but like vectors and constructors to have everything working nicely with respect to how C++ expects things to work. Or we can go for more C-like behaviors. So we don't do C++E things in here, right? And we just do allocations as a separate thing from the processing, right? So how do we handle this? Now, personally, I am used to using constructors and destructors with exceptions on. Without exceptions, there's an issue, which is if you do constructions, you cannot return an error code, right, from a constructor. So after the construction is done, you might be able to get like an abort statement based on whether it's initialized or not. That is the best you can do with respect to using constructors in this system, right? And another thing we want to do is use custom allocators. So allocating on custom allocators with a constructor can be a challenge as well. However, that is relatively easy with respect to like placement new allocators. So sorry, placement new operators. So you just do new, then place put the memory and the object and it just allocates itself on it. So no issues, but then the instructors have to be manually called. So what we will do is we will have cleanup as a function that is left as it is, right? And destructors don't necessarily need to exist. Similarly, constructors, since we're going to call a placement new separately anyway, we might as well uh, leave it to an init here, right? And instead have a default constructor that, sorry, and instead use, arrays that are basic if you anyway are using allocators, right? Hmm. Hmm. It's always a hard decision, but all of these have to be taken up front. If you make any mistakes with this, not mistakes per se, but if you don't pay attention to this, you come into problems later on. All right. Hmm. So what to do? Do we use vectors? Do we use constructors? Do we not use vectors? Do we not use constructors? I will make my life simple here. One of the things we can do is use the STL, right? Use the constructors and then use unique pointers on the custom allocators to handle everything else. So let's go with that. Init becomes a constructor. It has to be explicit because otherwise it will consider this as a cast. Generate a definition. We don't actually need the definition because we can just change this to render device and remove that, right? However, if we do this, we must provide the errors. So right now there's just aborts itself, which is fine because if this fails, there's nothing else to be done. We will also do a no discard bool is init. So we check if thing is initialized or not. This can be const. It will also be inline, but we can handle that at a later point to actually add it inside. Return instance and device, right? So if both instance and device exist, these can be false if they're null pointers, which means they're not initialized, or true if they are initialized. So that way we don't have any issues with this. We have a constructor now. We need an appropriate destructor for this. So that will be a pair of constructor and destructor. So not explicit, but just render device. So that's the destructor and create a definition. Destructor definition will just call cleanup, right? Cleanup itself will check if is in it, and if not is in it, then it will return. Because if it's not initialized, we don't want to clean it up. Simple as that. Doesn't make any sense for it to be cleaned up. Now, thanks to C++ and the way it operates, there is a certain set of things that we need to do. So it's called a rule of five, six. The rule of six or five, whatever you might want to call it, works like this. If there is a constructor, there must be a destructor, and there must be a few set of operators. So render device ampersand, so that's a reference return. Render device, so this is a constructor. It takes another render device as a constant reference, other, but we don't need it. And we should say delete. This is a copy constructor. It tries to copy this other thing in. Oh, you're right. So this is a, yes. The other one where we will use an operator equals. So this is an assignment operator for render device, const and we'll say this is also delete. What a delete operator, what these operators do is they copy. They cause copies of render devices. We don't want to do this. Render device is a single thing, single object, single ownership. So it will never be copied. Nothing else should have access to this, like in terms of creating multiple versions of this. And that is handled using this. Second is move operators. So these are similar in the sense we do render device, double ampersand. These are our value. And we can default these. Problem with defaulting is things like instance will just be copied. These are all primitive types. And if you just copy them, then there's no difference between a move operator and a copy operator, which is another issue. So instead, what I will do is I'll delete. What happens now, this means this object, once it's allocated, it will be pinned to a given location, right? The memory will not be allowed to move at all, which means it will automatically delete the given constructors for the superclass, which is app. So, okay, it says it's not initable, which is understandable. The other problem is we can't even do the relevant, we can't even make the relevant change here by making constructor sets, because you just cannot construct this particular operator, right? So we include memory that allows us to have unique pointers. So render device becomes std make unique, and we pass the given class, which is render device, right? So it will create the render device here. Init takes a reference to it, so we'll do a get and star, which can be a bit of a redundant get call. Yes, of course, we just do a star on it. Here again, since it's a pointer, it asks me to do these things. Cleanup is not required anymore. The destructor, okay, hold on. The destructor will clean it up, but it's better to do it. Okay, now, what else do we need to do? So, app state, again, it doesn't have its own constructor either. We will add that. So app state has a constructor now. It needs nothing. It will need a destructor since it's got the constructor. And since it has both of these, we need to do the rule of four, right? Now I use ReSharper. It's a free version. So I can do generate code and copy and move operations. So I can say these are both delete, right? And a finish, and automatically generate these for us. This also reminds me there's an error in render device that I need to fix. It's not exactly an error, but it kind of is. Not constructed, but So you can see there's a no except clause on the constructor on the moves. Moves cannot do exceptions because there's no way they can fail, right? Copy might still require you to create new allocations, but move does not. So we have to put that in. We will macro it out soon because these are relatively repeatedly used, but we can wait for it. App creation, we can add that here. Oops. Right. Return false goes away. Instead, we just return, so we just quit the process there. This is no longer required. If render device dot is in it, so we just check if it's not in it. Again, I have a habit of using these, so perhaps I should stick to them. So if it's not in it, then you return. So you don't do the miss data, you just return here, right? You know that the render device is not initialized. And finally, miss data init is something it will handle itself. These can be abort as well. So really, I don't need this. I can just say abort. Similarly, here I can say abort. Not that this makes a difference. Currently, it aborts anyway, built in, but we can do it, right? SDL log error, SDL log category error, category application, percent. There's no percent s. We just say render device failed to initialize. Right? So that is render device. We have used make unique here. That's not following the allocation practice that I want to follow. So what we'll do is we'll add allocations, allocators. We'll do that by using VC package to add Funathan memory. So that's Funathan memory. So these are a set of allocators that are part of C++ allocators that are provided by, I think it's Jonathan Muller, Funathan. Really nice. So they also wrap the standard library into these allocators so that you just use the namespace and the standard library and it will automatically work with a given allocator. It's downloading, so it's going to be a bit of time. But in the meantime, we can look at modernizing the remaining things, right? So render device doesn't work here. We do a star and that works. Seems to. Okay, moving on. Those will handle themselves. Another thing that we did last time we were cleaning up is we just threw things into misc data, right? So miscellaneous data. And these things are all frame related, per frame data. I like to abstract all of this into a frame manager. Okay. This frame manager is intrinsically tied to render device, which means all of these will actually just move to render device at the end. Okay, it failed. Why? Appstate init must return a value. We don't need init anymore. Okay. Similarly, destructor has not been created. We need to generate a definition, and all it does is clean up. Okay. Appstate is init instead. So we go to appstate and we create an is init. So notice card bool is init. This is const. It generates a definition which returns window and render device dot is init, right? All right. Actually, that can be null, so it actually has to check render device first. And that's that. Miss data can't really fail right now. Okay, let's integrate miss data stuff in. So we go to miss data, misc data, we take all of these, and the dependencies are a part of the frame, so we don't particularly care. The frame index, however, is a part of our frame management system. So we will move all of this out and we'll take them to render device, put them in here. Okay. Swap chain image count equals 3. This is something we also do not need anymore. Instead, we will have uint32t get image count, right? Or get num frames constant, and it does things here, which is it returns the swap chain images dot size as a static cast to this. Actually, actually, if I am right, we shouldn't need this at all. We remove this. Swap chain image count can be uint 32t, and this can handle itself. So that is fine. This is something we will work on. So go back. Okay. Now what is happening here? Each frame has a command pool, a command buffer, image acquired semaphore, render finished semaphore, and frame in use fences. So each of these things we can move to a single struct called frame, which I'll just do here for now because it's easier for me. Frame. And inside frame will be command pool. We'll have a command buffer. This will probably come out later because you use more than one command buffer in a frame. Semaphore. So this one is the image acquired semaphore. There's another one which is render. I hate this particular thing. I need to add a feature for this where we can move word by word. Render finished. And finally vk fence frame ready to reuse. Right? That's a frame. So all of this can become a single std array for frame. Instead, we will use vector here. Okay. And I'll come to why we're using vector here, because this allows us to have as many frames as there are swap chain images in flight, which means that there are four swap chain images, we can have 4 frames running. Or more importantly, this allows us to runtime configure the frames. Now we can actually work at this, which is return frames dot size dot static cast, right? So that gives us the number of frames, and there's no issue here. No discard. All right. Frame index. So this keeps a cursor of the current frame. That is fairly useful. And that's that for frames. We move here. Again, it tries to do all of this using MISC. Instead, it will start using the renderer. So let's do that little bit. So instead of doing this, you will get a current frame, so which is render device frame current frame equals render device frames, actually render device dot frames, render device dot frame index. Okay, so that gives us the current frame. Then we can get the fence from the current frame and stuff like this, which we don't even have to do. So this gets changed into current frame dot image acquired semaphore. We don't need that either. Fence becomes current frame dot fence. Image acquired semaphore becomes current frame dot image acquired semaphore. Fence becomes current frame dot frame ready to reuse. This is current frame dot command pool. Mhm. Current frame dot command buffer. This again will be a little changed later, but otherwise it's just the same. Current frame dot render finish semaphore. And since this image acquired semaphore is current image dot image acquired semaphore, we can actually just take this and replace it here, right? Frame index will become render device dot frame index to be changed. Pens render finished. Pens becomes current frame dot frame ready to use. All right, done. There's one error here, which is frame index in misdata init. We don't care because that is going to be init inside the rendering device. Again, frame index equals 0 is something we will set up ahead of time. And we can move on from here. So build solution. Let's see what's happening. Command pools undeclared identifier. Where is this? Right, this is initialization code. So all of this initialization code needs to be moved into the rendering struct, right? What we'll do is we'll just rewrite those because they're not that hard to write. It will be less effort really. So frame, let's copy the construction structs. Command pool is the first thing we need in the frame. We will create a constructor for a frame, which takes a vk command pool creation first, which requires the rendering device. Device const and rendering device, right? This, then it needs to also do the command. So this will be vk abort. So abort if failed, vk create command pool rendering device dot device. Command pool create info is command pool create info. Allocator is null pointer. Command pool is and command pool. This is ampersand as well. Okay. Moving on. So that's command pools. Then this is command buffer allocation. That is relatively simpler because there's only one of it. Remove the index, we don't need it. Command buffer is a single command buffer. Device, since we will keep reusing it, we can create a device up here. So vk device equals render device dot device. It's just a getter. This can be const, I believe, and that's it, right? So that constructs command pool, then it constructs command buffer allocation. So it's not constructs, it allocates command buffer, and we have to follow this up with everything else. As you can see, a lot of grunt work really. So semaphore, we can share the create info between all of these, which is nice. So semaphore can share construction info. We don't need that many of them. There's only one. So we can remove that. And semaphore becomes the named semaphores instead. Render finish semaphore. Frames in new fences again goes away. Instead, it's called render finish. No, it's called frame ready to reuse, which makes more sense as a name, right? Again, begin and end. And that is it. I don't think I need these because it's a short function. Hmm, That we have formatted it. Shadows field of render device. Yeah, because the frame is a sub built class, but we will move it out. So there it goes. One and two, right? Render device adds a forward declaration. These will have to move out of the class, but we will start actually separating these, right? So step one, we can add a new class. Class name is frame. So frame.h, frame.cpp. There's no base classes. Even though I call it a class, I will make a struct. Then the whole frame here just gets moved into the frame.h. Okay. And you need Vulkan, so include, but before that, we need to actually check the includes here. We need to be careful with these. Not all includes work exactly the same. So instead of Vulkan, actually, we need to include Volk. Oh, over here, we do the Volk in it. Render device needs a forward declaration. That will be a forward declaration, all right. And this will be moved. So first it's explicit, second is moving definition out of the scope. All right. And here we can include the render device. So include, we don't have render device separated either. So let's move that out too. Frame import, we'll add forward declaration to this as well. Then render device, we will add new class. So that's new item. Oh, yeah. Add new class. Class name is render device. Let it do that. Create it. Go back. Copy the whole render device, including each of its class member functions, definitions. Okay, I think that should be all of them. Move them into this file. Again, it needs Volk at the top. So hashtag include Volk. That is fine. It needs vector. So we move vector there. It needs frames, which will be, oops, I don't want to include it. It will be a forward declaration. SDL window, again, it needs SDL, which is its own line. And yeah, this requires SDL welcome. Hello. So Arpit, hello. We need to refactor these macros and functions. So all of this will have to be moved in a global scope somewhere. Can you hack a website now? What? I don't do web development. So I'm just gonna call it utils or macro utils. Add pragma once again, that's not a problem. We just have to take this. And paste it into macro utils. Right? We can check cannot involve the symbol assert, stack, include, c, assert. Well, you can just keep chatting here and that should be just fine. So abort if failed for result is just the assertion there. Uh, hmm. If it's just going to do vk check anyway, we can remove it, right? All right, macro utils are done there. No, I do not have Telegram. So, alright, that's macro utils. So render device can include it if required, but these are all operations that will be moved to the CPP class, CPP file. So we'll actually do that first. Move it to CPP file there. Now we can change Control F. All about if fails becomes VK check. Place all at once. Go to the top. We need to do include the other includes. So include macro utils SDL. So include SDL3 log. I'm making a game engine. Well, actually, just the rendering of a game engine. So the 3D graphics part first. We can look at the other parts if required, if and when required. It's fine. Template argument deduction failed because we haven't included array. So that is done. It needs width and height, and it needs the clamp. What I will do is I will get another library called GLM in. We will be using it later for mathematics, right? So this is OpenGL mathematics. Actually, let's check something. GLM. How can I learn from this? This is not exactly a tutorial stream. There are a lot of very good tutorials for this online. So you can check out learnopengl.com, the site. This teaches you how to do all of this quite well. There's also a book and everything. So you can follow this, learn from that, and then move to Vulkan. Again, you have vulkantutorial.com right there, which is also pretty good. So once you do OpenGL, then you do this and you move on. There's also DirectX and there's also other techniques. But yeah, so just choose one of these and decide. So GLM SSE to support. So does it have macros? How good a macro does it have? SIMD. Okay. These require specific SIMD supports. Meanwhile, I could use the DirectX math. So DirectX math clamp. Let's see if it exists or not. It has a vector clamp. Okay, I'm not going to use GLM. I will use a math util. So add new item, header, call it math util, pragma once as normal. Go up there. Nope, this is the wrong file. Blaze, yes, clamp, and that goes into math util, right? This is for Uint 32T specifically, but is there really no clamp in there? That is actually sad. Header should have an inline specifier. Yes, it should. So inline. We will make this templated. So template. There is an std numeric. So std actually is comparable. Std compare. P. I think it's in type dates. Type dates. Std concept comparable. think it's called ordering. Totally ordered. Okay. And this partially ordered. I'll just do totally ordered for now. We can look at the rest later. So totally ordered, and so this becomes T, T, P, P, and these are fine, right? Max is completely fine. This will keep working by itself. So inline is no longer required. Type traits is not required. CSTD int is not required, which is good for us. Let's build it. Lamp identifier not found. Include math utils. That's a bit of work. Okay, what else is missing at the moment? Width and height. These two can become inputs to render device creation. The way I like to do this is instead of having the inputs as a list of objects, we do a create info. So here I will say something like create info, struct create info, which will contain an STL window pointer called window, uint 32t width, uint 32t height, just semicolons. Okay, and then we will just take a create info const ampersand. So that will take create info by generate definition. We don't actually need this. It will take create info as a constant reference. So we can here take the create info const and it's called create info, right? Then we can just fix these things. So this becomes create info.window, create info.width, and create info.height. All right, that is good. Has different names, create info and window. Yeah, because I didn't rename it here. Create info. Okay. And that will help us create this thing. But the benefit of doing this is we can add defaults. So I can say that a standard default is or actually 640 by 480, right? While window doesn't have a default. So here I can put a null pointer. Otherwise it will say it's actually we can make it compulsory doing this. So let's see now. Where are we? Render device is in it. Render device is incomplete because it's not added here yet. So include render device and continue on. So SDL window has been created. Window is cannot be used there. Instead, it will take a window equals window, right? Make unique. Oh, it's having troubles with make unique. Okay, so I pass in the create info to it and it will automatically now start working. I'll just do this. It is fine because it has a null pointer as the window. We need to do an assert for it. So equals null pointer, and inside the constructor we need to assert. So assert create info dot window. Okay. Next, I will add a message to this particular thing. So it's and msg like that. This way we are forced to tell what the assertion problem was. It can be nice, but hmm, I think it's fairly self-explanatory in this particular case. All right, build solution. Let's see what else we have to do. So here, render device is incomplete. Include render device.h. Now it's complete. Abort if failed can be changed to vk check. We control and replace all of it. We include macro utils and build. Okay, this has no issues. Render device has no issues, so it's just in here now. Abort if failed, so that's the easy low hanging fruit. Done. It's all vk check. Second is render device frames don't exist, so frames are separated out, and we need to include the definition. Done. So all of that is fixed. Creating command pools and swap chain, all of that is no longer required here. So yay. Finally, destruction. This has to be moved into the right place. So metadata cleanup doesn't need it anymore. Instead, frame destructor does need it. Let's see if frame destructor is even there. So it's not. Frame. And we will generate the destructor. There we go. We don't need that. Okay. Device. So vk device const device equals render device. So each frame now needs to hold a render device, which is not very nice. Okay. So instead, the way I will handle this is to make it reliant on something else. So here I will warn if the frame is still initialized, I will warn that a frame has to be deleted. So SDL log error frame needs to be deleted manually. Okay, each frame is owned by its parent, so this needs to happen. SDL log error requires SDL category error. All right, and this should only run if it is init. Okay, and the frame needs an is init, so we will create that. No discard bool is init const done is init generate definition return to each thing in order, right? You have a command pool and you have command buffer, we don't care. You have fence, so frame ready to use fence, and you have we don't need to check all of these. If there exists a command pool, we are in trouble. We need to clean up. So if it's init, if command pool exists, then frame needs to be deleted manually. That's the end of it. Other than that, frame movement, because it is a part of a vector, because it is inside a vector, you need to be able to move this. So you can't just say this is not movable. So we do edit generate code. This is a resharper thing. Instead, we do copy. I say implement. I can do swap base assignment. I can finish it. So now copy constructors are automatically deleted, but the move constructors is manually implemented. It swaps, which is nice in this particular case for the assignment. It only generates one assignment, and that's not good. That's not what we want. So I'll just create the other one. Frame ampersand operator equals constant other and deletes. So no copy allowed. Okay, frames cannot be copied. Hold on. Since frames are owned by uh, by the creator, it doesn't care. We don't actually care if it's copied or not, right? We act, we just have to call cleanup from one place, and it takes a render device const ampersand render device as the requirement for cleaning up. Generate definition. So it has to generate that. How do we do that? So I forgot to vk device. So it gets a device which comes from render device dot device, right? Now, for each of the things that we have, we will do vk destroy. So we can do vk destroy command pool device command pool null pointer. Copy paste 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 paste. So this command pool, then there is fence, there's semaphore 1 and semaphore 2. Then destroy command pool here becomes destroy fence. This becomes destroy semaphore. This becomes destroy semaphore as well. And that's it. We're done. If is in it, if not is in it, then this returns. And we don't have to do the rest of the things. So that's the cleanup. Can be made const. That's not good. All of these need to be taken out. So this is another macro I like to use, which is define take. Do it with a small because that's what I prefer. Object, and take is implemented using std exchange object and the default value for that. Now this could be a function instead of doing a macro. The reason I use a macro instead of function for this particular case is because it saves me from perfect forwarding and all of that bother. What this does is it simply takes the command pool, and after taking it sets it to the default value, which in the case of our current parameters is null, right? We've done it for this cleanup, and this reminds me that we have to do it for the other cleanups. So go to cleanup, we take swap chain views. This is not a problem. View has to just be clear. So swap chain views dot clear. We can also do that for the images and clear it. This has to be taken. So we take that. Destroy device. Again, that's a take. Destroy surface. Surface is a take. And destroy instance, which is a take. There we go. All right. Now, if you want to be pedantic, you can add a take here, but since we're clearing it, it's kind of pointless. So frame is deleted there. So if you double call frame, we'll have an issue, but otherwise we're fine. If it's in it, then we will say that, hey, you have done a big problem. In fact, we can assert it here. Assert not is in it. In this case, I can actually say that. Manual cleanup required. Okay, this done, we can go back to render device cleanup, and before we start any of the rest, for auto const and frames. So take for each frame. This I don't think can be const. Right? It's a frame and frame dot cleanup. All right, and it will take this. Start this really. Cool. So that will clean each frame up. We can do frames dot clear, and we move on from there. Build solution. It's all right. It has succeeded. It won't work because we did not initialize the frames, or did we? So chain image views, and we end there. So after this, frames have to be initialized. So here for int I equals, how do you create the frames? For int I equals 0, I less than swap chain count, which doesn't exist here. So we can do swap chain images dot size plus plus I and frame dot create. So that's frames dot pushback star of this emplace back. So emplace will construct it automatically. Size is no go here, so we'll add that as another int, comma, and make this u int 32t. So I end equals swap chain images dot size dot static cast u int 32t end, and we're good, right? So that creates all of the frames for us. Build solution, vector mitigation. What? Where is this? It's for emplace back. And is checked, range checked by comparison in this line. Okay, we can move the end out. We can brace this so that end doesn't go out of the scope. Semicolon here, option images dot size, frames dot reserve because we don't want it to construct it, end, or call it count. So count and not equals count. Build solution, much better. One succeeded, no problem so far. All right. Let's see if it actually gives us a triangle. It does. So great. We've managed to refactor that little bit. So miscellaneous data, the MISC data thing, that field is just arbitrary things that are part of our current usage. Okay. Frame is all the data that we have that is per frame in use. Render device is the general usage that entirety of Vulkan has. All right. And that's the current design that we're going for. And similarly, app state will be removed out of this into another place where app state will be initialized. So after this, another little design decision, let's say, little, quote unquote, I don't, you can't see me make an air quote, but I am making air quotes, is Punathan memory. Since I have it, I will start using it. So that's include Punathan memory, and we'll add allocators here. So first would be a simple allocator. That one is a block. It's called just allocator. Okay, let's actually check the documentation. Nathan memory. How do we use it? So there's a container for containers, memory pool for memory pools. These are fine. We don't want static or temporary allocator. What we want is a simpler block allocator. So that one is a heap allocator, I believe. So what's a block allocator? Low level allocator access. So let's see. Hopefully there will be a bit of an understanding here. Memory stack. Nathan. Memory stack. What is memory stack? Memory arena with a given block or raw allocator. The managers use memory block for higher level allocator. To a certain extent, this is what we want. The arena takes from a block allocator. So block allocators like this. Okay. And non-zero initial block size and multiple further optional arguments. We'll always allocate in blocks. So on. Okay. So first of all, we'll add containers here. Namespace, alias. Then we don't need memory pool right now. We instead need a block allocator which comes under raw new allocator. I think new allocator. It's not here. No, that's still memory arena. So yeah, this is what I want, raw allocator. The question is, how do I create the raw allocator? So if you look at memory pool, it will automatically have a given raw allocator. Sometimes it almost feels like it will be easier for me to just use custom handwritten allocators, but it doesn't work if I am using STL. So default allocator. That's the default allocators, which will be used as a block allocator in the raw arena. Yeah, I don't particularly have a problem with that. Let's reverse engineer it from memory pool. So memory pool, go there. Memory pool leak detector. I don't particularly care about that. This takes a default allocator as its block or raw allocator, right? So that's it. What we need to do is create a raw allocator. A block allocator is a raw allocator. No? Raw allocator is a completely pure raw allocator. Yeah, I think we'll just have to use arenas. Memory arena. All right. So an app state, the entire app will have an arena which takes a block allocator as a backing and cached. Whether it's cached or not, memory arena is the memory, so I won't say anything about it. It does definitely need a block allocator. Default memory default allocator. Okay, so the arena that the app state uses is the default one. Low level concept that will use as a block allocator. No, that's the wrong one. Arena cache, we don't care about that. This is one thing that kind of irks me here. But it should be all right. So app state constructor requires the arena to be created first, which is great for us. So it needs a block size, which we will say is 4 kilobyte. Memory sizes is a different include. We will need smart pointer. Big. Nope. We already have namespace alias. Delete. No, 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 no. There's a kilobyte. So if we go to Funathan memory, we'll see that there's a kilobyte thing that they use, 4 KIB. Where does that come from? I think it comes from this namespace. Funathan memory is a memory for easy access. That's fine. Little trick, little strong trick. You paste all of it, save. Kilobyte still doesn't work. That was definitely not one of the things. We can try to find it. Kilobyte just needs that kilobyte. Okay, I'm at a little bit of a loss about this kilobyte business. So I will simply do it myself. So you size t operator, take something, KIB gets as input given size t value, and it returns that given size t value multiplied by 1024. And we made a const, no problems with that. Would have an inline specifier. Done. Would also have a const expr specifier. Remove. Okay. AIB, MIB, GIB. So this would simply be 1024 times 1024, and this would be times 1024 times 1024. Okay. Build solution. And the reference inline function has been removed. Mathutil. Do we not have it? We don't have it. Cool. Kilobytes has been set up. Okay. There's a little thing that we will face later on, which is the memory will not be enough. So this has to be 4 megabytes at least, or we can directly go for gigabyte. So we directly allocate 4 gigabytes. The entire system has to run within 4 gigabytes or it just won't run. This will throw an exception. This is not part of the normal control flow, let's say, which is not nice for us because we're not wanting to have exceptions in this. But at the same time, if memory allocation fails, that tells me that there is a very big problem within my system. So having an exception doesn't matter here. And in fact, all of these aborts can also be exceptions. So big questions. Big questions. Operator, KIB, and reference inline function has been removed. Don't know what you're talking about. I'll probably fix it. I'll probably add the actual inline functions in there. Static assertion failed. Block allocator is not a block allocator because it's a default allocator. So this memory arena is no good for us. Player type that stores and how it's controlled. Storage policy and the mutex. Direct storage will store the allocator directly. Reference to allocator. Reference storage sounds good to me. Takes a raw allocator, which is the default allocator. This is just the storage. Not exactly what we wanted. Block allocator is not a block allocator. You know what? I'll do this offline. I'll figure out how to do this allocator business, learn this library, and then I'll come back to this. Cheers. It was fun doing this. We'll see again this thing later. Goodbye.